that we have understood what artificial intelligence is, let's take a look at its major domains. AI isn't just one single technology, it's an umbrella term that covers multiple specialized areas, each solving different types of problems and mimicking different aspects of human intelligence. From making predictions and understanding language to seeing the world and even controlling robots. Each domain plays a vital role in making AI truly intelligent. So, let's explore the key domains of artificial intelligence that are shaping the future around us. Artificial intelligence is not just one technology, it's a vast field made up of multiple specialized domains. Let's take a guided tour through these domains one by one, starting with the most relatable one, that is natural language processing. So, natural language processing enables machines to understand, interpret, and generate human language, both spoken and written. It's the magic behind chatbots, translation apps, voice assistants like Siri, Alexa, and even tools like ChatGPT. Natural language processing helps bridge the gap between the humans and machines using language, our most natural form of communication. Next we have is computer vision. Computer vision allows machines to see and make sense of visual information, images, videos, and real-world scenes. It powers the facial recognition, object detection, surveillance, autonomous vehicles, and even medical image analysis. With computer vision, machines can detect, identify, and react to what they visually perceive. Next, let's come to a very vast topic, which is machine learning and data analytics. This is the engine of modern AI. Machine learning enables the systems to learn from data, to recognize patterns, to make predictions, and improve over time without being explicitly programmed. Paired with data analytics, it helps businesses forecast trends, detect fraud, personalize services, and automate decisions. From Netflix recommendations to stock market predictions, machine learning and data analytics are everywhere. Now let's move on to robotics. Robotics is where artificial intelligence gets a physical body. It combines the sensors, actuators, and intelligent algorithms to perform physical tasks, from assembling cars to assisting in surgeries or exploring Mars. With artificial intelligence, robots aren't just machines. They become autonomous, adaptive, and smart. Next are the expert systems. They are designed to simulate the decision-making skills of a human expert. They rely on knowledge base and a set of rules to solve complex problems. Used in fields like healthcare, finance, and law, they deliver consistent, explainable solutions, like a digital expert available 24 into 7. Next we have is generative AI and large language models and beyond. And now we enter the latest and most exciting frontier, that is generative AI and large language models like GPT-4 and beyond. These systems don't just analyze, they create. From writing stories and generating code to generating art and simulating conversations. Generative AI is revolutionizing the content, creativity, and productivity. It marks a leap forward from intelligent automation to human-like innovation. So those are the powerful domains that shape what AI can do today, from understanding language to creating it, from analyzing data to interacting with the world. Now let's start with what natural language processing or NLP actually processes, and that's text or speech given by humans. It could be a sentence you type into Google, a voice command like what's the weather today, or even a long customer support email. The input is natural human language. Messy, emotional, often full of slangs, and definitely not always grammatically correct. So what is the purpose of NLP? The goal of NLP is to help machine understand, interpret, and respond to human language in a meaningful way. It's about making sense of what we say and turning it into something a computer can process. Ultimately, NLP allows the machines to communicate with us, not in the code form, but in the language we speak. Now, what are the key technologies in NLP? Here are the main tools and techniques used in natural language processing, starting with tokenization, that is, breaking down sentences into words or parts. Then we do part of speech tagging, that is, understanding the role of each word, noun, verb, adjective, etc. Then we do named entity recognition or NER, that is, identifying the names, places, dates. Then parsing and syntax trees, that is, analyzing the sentence structure. Then sentiment analysis is also part of NLP, that is, figuring out the emotion or opinion in the given text. Then is machine translation, that is, converting one language to another. And also speech recognition and text to speech conversion, that is, converting the voice to text and text to voice. Large language models or LLMs like ChatGPT or BERT that generate or understand complex human-like responses. Real world examples of NLP. You interact with NLP almost every day without realizing it. For example, voice assistants like Siri, Alexa, Google Assistant. Then spam filters. NLP reads the email content and flags the unwanted emails as spam. Chatbots and virtual agents like in banking or customer support websites. Then we have search engines. NLP helps them understand your question, not just keywords. Then grammar and writing tools like Grammarly, Google Docs, suggestions. Then language translators like Google Translate, DeepL. Then social media monitoring, detecting toxic comments, fake news, or sentiment trends. All of this is part of the natural language processing. Unlike NLP, which takes in words, computer vision works with visual data like images, videos, live camera feeds, or even X-rays. Anything a machine can see, computer vision can try to understand. It could be a selfie, a road scene, a scanned document, or even footage from a drone. Now, what is the core purpose of computer vision? It is to enable machines to see, interpret, and understand visual information just like humans do. It tries to answer questions like what is in this image? Where is the object? What's happening in this video? In short, computer vision gives the machines the power of sight and perception. Now, some of the key technologies in computer vision are like image classification, that is identifying what's in an image. For example, it is a cat versus it's a dog. Then is object detection, that is locating objects in a scene. For example, detecting pedestrians. Then semantic segmentation, that is labeling each pixel. For example, this part is road, that part is sky. Then you have facial recognition, that is recognizing faces, emotions. Then we have optical character recognition or OCR, that is reading text from images. Then we have pose estimation, detecting the body movement or gesture. Then is CNNs, convolutional neural networks. This is the backbone of most of the computer vision models, that is CNNs. Then we have the edge detection or filters for highlighting shapes and textures. You've probably used or seen computer vision applications more than you realize. So let's see some real world examples of computer vision. For example, the face unlock on phones, that is facial recognition. Then self-driving cars, that is detecting the lanes, the pedestrians, the traffic signals. Then you have social media filters like Snapchat, Instagram AR filters. Then medical imaging, analyzing X-rays, MRIs, CT scans. Then you have retail surveillance, tracking footfall, shoplifting detection, scanning documents, apps that turn photos into editable text. Then you have robotics. Robots also use vision to navigate or interact. So basically, computer vision turns your camera into a brain. It helps the machines not only look at the world, but understand the world, analyze it, and react in real time. Machine learning and data analytics thrive on one thing, that is data, and lots of it. The input could be numbers, it could be text, it could be images, clicks, sales figures, sensor readings, or even your Netflix viewing history. Basically, anything that can be recorded and measured becomes fuel for machine learning. Now, what is the purpose of machine learning and data analytics? The ultimate goal is to find patterns, make predictions, and enable machines to learn from experience, just like humans do. While data analytics helps us understand what happened and why it happened, machine learning takes it a step further and tells us what will happen next or what to do next. Together, they drive intelligent decision making. Now, what are some of the key technologies in machine learning and data analytics? Here's what powers this domain, starting with supervised learning, that is, learning from labeled data, for example, spam mail or versus not spam. Then you have unsupervised learning, that is, finding hidden patterns in data, for example, customer segmentation. Then we have reinforcement learning, that is, learning from trial and error used in games and robotics. Then we have classification and regression, that is predicting categories or numbers. Then is clustering and association, that is grouping data or discovering relationships. Then we have feature engineering, that is selecting the right input signals. Then model evaluation and tuning, that is improving the accuracy and performance. In data analytics specifically, we have descriptive analysis, that is what happened. Then we have diagnostic analysis, why did it happen? Then predictive analysis, like what will happen? And prescriptive analysis, that is what should we do? Now, some of the real world examples of machine learning and analytics are, here's where you see this domain in action every single day. Now, the moment you open your Netflix and YouTube recommendations, it starts suggesting you what to watch next. Then we have Amazon and Flipkart. They give you personalized shopping suggestions. Then we have banking, where they do fraud detection and loan approvals. In healthcare, they predict the disease risk. Stock market, they follow the trend forecasting and trading bots. Then chatbots and virtual assistants, they learn from user queries. Then travel platforms, they help with dynamic pricing and demand prediction. So machine learning and data analytics are like the brains of artificial intelligence. They take messy data, they make sense of it, and they help machines get smarter with every interaction. Basically, they don't just find the needle in the haystack, they predict where the next needle will be. Robotics starts with sensory data. What the robot sees, hears, feels, or measures. This could be from cameras, ultrasonic sensors, temperature gauges, pressure pads, or even LIDAR scans. Just like our senses help us understand the world, robots they rely on sensor inputs to make decisions. Now, what is the purpose of robotics? The mission of robotics is to perform physical tasks in the real world, either autonomously or under human control. Robots are AI's hands and legs. They don't just think, they act too. From assembling cars to exploring Mars to vacuuming your floor. They take smart decisions and execute them physically. Now, there are key technologies in robotics. Here are the major control systems that make a robot function and make it very, very intelligent. starting with perception, that is sensing the environment, for example, cameras, infrared, ultrasonic sensors. Localization, knowing where it is in space, for example, GPS, SLAM algorithms. Then mapping, creating a map of its surroundings. Path planning, figuring out how to get from point A to B. Motion control, that is managing movement, for example, motors, actuators, balance. Decision making, using artificial intelligence and machine learning to decide what to do. And manipulation, that is interacting physically with objects, for example, robotic arms, grippers. These systems, they work together in real time to help robots think, move, and react like intelligent beings. Now let's look at some of the real world examples of robotics. Robots are generally deeply integrated into our lives, like industrial robots, welding, painting, and assembling in factories. Home robots, Roombas, mopping bots, lawn mowers. Then autonomous vehicles using robots to steer, stop, and sense. Medical robots assisting in surgeries or delivering medicine. Humanoid robots used for research, entertainment, elderly care. Exploration robots, space rovers like Perseverance on Mars. Then drones, delivery, military, and agriculture. Robotics is where artificial intelligence meets the real world. Not just thinking, but doing. With smart sensors, clever planning, and powerful motivation. Robots are no longer science fiction. They are our co workers, helpers, and even astronauts. Now let's explore the next domain, that is expert systems, the classic brainy side of AI. Expert systems take in structured queries or facts, like symptoms of a disease, answers to diagnostic questions, or technical inputs. Basically, they start with clear user input, usually in the form of system that can easily process and match with known rules or data. Now, what is the purpose of expert systems? Expert systems are designed to simulate the decision-making ability of a human expert. Think of them as the OG of AI, created to analyze complex problems and offer recommendations, diagnoses, or solutions just like a human would. They don't learn from experience like machine learning. Instead, they follow a set of predefined rules based on expert knowledge. Now, what are some of the key technologies in expert systems? An expert system typically has three core components. One is the knowledge base, a library of facts and rules. For example, if fever plus rash, then it means measles. Second is the inference engine, the brain that applies logic to match the input with the rules and draw conclusions. And the third is the user interface that allows users to interact and receive advice or feedback. Some of the optional modules are like the explanation module, which explains how the decision was made, and knowledge acquisition module that allows the experts to update the system. A real world example of expert system would be that you might not see them directly, but they're working behind the scenes in many fields. Like mycin, one of the earliest systems helped diagnose bacterial infections. Next, we have the loan approval systems, decision making based on financial rules. Like chemical analysis tools, they suggest the best tests or reactions. Technical support agents, they troubleshoot based on structured inputs. Legal advisory systems recommend legal action paths. Agriculture systems provide advice on crop disease based on symptoms. Military systems, they assist with the threat assessments and tactical planning. Expert systems were AI's first attempt to bottle human wisdom, turning expert knowledge into digital rule books. They are like having a specialist available 24 into 7, ready to diagnose, decide, and explain, all without ever taking a coffee break. Generative AI takes in texts, images, audio, or even prompts and transforms them into something entirely new. A short phrase like write a poem about space or a rough sketch can become a full article, painting, or music track. It's like giving a spark, and then artificial intelligence creates the fire. The goal of generative AI is simple but powerful. That is to create. Where traditional AI analyzes and predicts, generative AI imagines and produces text, images, videos, voices, code, and more. It's the creative brain of artificial intelligence, unlocking expression, innovation, and automation. Now, what are some of the key technologies in generative AI? Here's what powers this futuristic domain. Starting with large language models like GPT, Gemini, Claude, used for text, dialogue, and coding. Then are the diffusion models used for image generation like DALL-E, Midjourney. Then we have the generative adversarial networks or GANs, two neural networks that compete to improve content creation. Then we have the transformer architecture, the secret sauce behind almost all LLMs. Then are the multimodal models, AI that can understand and combine text, image, and audio inputs like GPT. It also includes tools like text to image, that is DALL-E, text to video, Sora, voice cloning and music generation, code generation, for example, Copilot, AI storytelling, game world building. Now, what are some of the real world examples of generative AI? Generative AI is changing nearly every field, like ChatGPT, Gemini, Claude, answering questions, writing essays, and coding for us. Then we have DALL-E and Midjourney, turning words into art. Then we have Runway and Sora, creating videos from text prompts. Then there are so many AI music tools, which compose music in seconds. Then we have AI coders like Copilot, Code Whisperer, writing entire functions or fixing bugs. Then are the content creators, that is, auto generating blogs, marketing posts, and captions. Healthcare AI, generating medical reports from scanned summaries. Game development, building characters, levels, and even storylines with AI. So, generative AI is not just a tool, it's a creative partner. It's where the future of AI gets personal, emotional, expressive. We are moving into an age where AI doesn't just think, it dreams, it designs, and it composes. This is AI unleashed. AI isn't just a set of separate tools, my friends. It's a team of superpowers working in harmony. Imagine this. Natural language processing reads your message. Computer vision looks at the environment. Machine learning and data analytics understands the trends and makes predictions. Robotics puts that decision into physical action. The expert systems offer logical, rule-based advice. And generative AI adds creativity, filling in the gaps with imagination. Now, let's say you're building a smart hospital assistant. Then NLP listens to the doctor's spoken instructions. The computer vision scans a patient's MRI in real time. Machine learning predicts the recovery time based on patient data. Robotics delivers the medicine to the right patient room. The expert system suggests the next steps based on symptoms. And generative AI writes a report or even creates a recovery video for the patient's family. This is not science fiction. It's artificial in collaboration. Each domain is powerful alone, but when they come together, they become something much bigger. A full-fledged intelligent system that understands, acts, adapts, and creates. That's the future we are stepping into. And if you are learning AI today, you're not just learning tools, you're preparing to orchestrate intelligence. So stay tuned, my friends, because in the next video, we'll break down how to choose the right AI domain and how you can become a creator in this intelligent revolution.